Hi guys. So, unfortunately, yesterday was a rest day, so we did not have neither contests nor practice problems. So today I wanted to fix it because it's Monday, and I've seen a suggestion in the comments to sort of uh, start from the easier problems on Monday and increase the difficulty gradually to get to some like red problems on Thursday and Friday. And I think it's fairly reasonable this way. We have like a fairly intuitive schedule and yeah, cover a broader range of difficulties. But unfortunately, I have not prepared a problem in advance, so we'll try to find something as we go and solve it as we go. Let's go to problem sets and think about what do we want to solve. First of all, we want to solve something in 16 to 18 range today, I believe, because that's around expert. And there were suggestions to solve some expert problems. We can as well just try those guys, because why not? Yeah, let's just try, in order. We'll try to go through like 3 of those, I guess. That sounds reasonable. So one of the problems is what it is. 1552D. Array differentiation. We're given a sequence of n integers. Does there exist a sequence of n integers such that the following property holds for each I from 1 to n? There exist two non-necessarily distinct indices j and k such that ai equals bj minus bk. What's the point? Oh, we want to find bj. Okay. Alright then. We have several test cases. We have array A of size n. We want to find an array. No, we want to check whether there exists an array B such that pairwise differences of B give all possible values of A. Well, first thing that comes to mind is to set something like B0 equals, let's say, 0, and B1 equals B0 plus A1, or I should say plus B0 plus A0. And B2 equals B1 plus A1, etc. Like Bn equals Bn minus 1 plus An minus 1. The only problem, like obviously pairwise differences of B cover all possible values of A. The only problem with here is that B is actually has n plus 1 elements, and we only want it to be n elements long. And therefore some sequence must like we can't have that, and therefore like with such construction we can get all AIs but one, and then it sounds natural to start thinking whether we can do something smarter. like one natural idea is to just contract these guys and then hope that the last AI will be a sum of several other AIs. And I think that this is more or less what we want to check. More precisely, I think that we want to check that there exists several sets of indices, such that AI first plus AI second plus something like that is equal to a J first plus a J second plus a J else. Because this way we are able to save one or not this way. Nah. Does it actually save us one value of B? So the point I'm trying to make that that's a graph, right? So here we have like the vertices are numbers of B from array B, and then the edges should have lengths from A. So this is one like AI first, AI second, AI case. Here we have a J first, a J second, something AJ, AJL, I believe was the letter I used. This way we have total of K plus L AIs satisfied, and at the same time we only spent like how many? 1, 2, 3 K plus 1 here, also 1, 2 L minus 1 vertices here. So overall we spent like K plus all vertices, and then everything else we can just depend here, here, here. So the question becomes whether there are two subset sums of AIs that there are the same, because there is no other way we can save one vertex, right? Usually when you have like n edges, you need n plus 1 vertex, unless n plus 1 vertices, unless you are able to somehow like get a cycle, and the cycle is basically like some AIs go in one direction, some AJs go in the other direction. So it sounds like we just want to check that. Want to check like the answer is no if and only if all subset sums are distinct in AI. Oof. Okay, I mean like subset sums, right? It's actually fun that the last like topic video we had on Friday was about subset sums, and here we get like purely on luck yet another problem. But I guess like actually you can like think in terms of bit masking as well, so we'll try to do both of these approaches. I guess that will be more educational. So what we want to check is that size of subset sum is equal to 2 to the power of n, because that means that they are all different. And if this is so, then we print a yes, otherwise we print a no. Let's check if we got it right. Why exactly? Oh, because that guy is size. Well, not a big deal. Oh, I just messed up the... Yeah, right, exactly. Because like, if they are all distinct, then we can't save any values of b. We need to use them all, and that's not what we want. So I just messed up the order of answers. So now we get yes, yes, no, yes, yes, and we don't care about negative numbers. I think we don't care. Once again, like that, it just means the default direction for them is different. It does not mean that anything more important is wrong for them. Okay. Oh, for some reason I have pi here, but that's... Let's go here and I guess check. Like it should be working out because n is only up to 10, so that is 2 to the power of 10. Right, no problems at all here. Another way, if you don't like this way of having subset sums, definitely possible to do another way. So we'll loop our masks this way, this time. The way bit masking works is like ith bit determines if we take the corresponding element or not. There are, however, several drawbacks to this approach, which you will see quite soon. So, and we loop our bits. There are up to n bits. You say like, okay, if mask has this bit turned on, then sum naturally increases by ai, rather by a bit, and then subsets are sums we can insert as here. Should work just fine. I did not press that. Yeah, well, you can see the answers have not changed, so let's submit this version as well. Personally, I think that this is, well, like, first of all, that's longer to implement. Second, technically, like this runs in 2 to the power of n time. This runs 2 to the power of n times n time. That's a little bit slower, because like here we implicitly know which bits we took, which bits we did not, so like we can disregard this for loop, get rid of it. This one is like in theory it's a little bit slower. This one should be a little bit slower in practice, because in order that gets some constants that we use like more here, I believe, than here. Well, this one is fast, but like, so. Yeah, so in general, I think that this one may be faster in practice, but hey, like it takes more code and it's less intuitive to implement. You need to understand exactly how bitmasks work, and well, you may not want to do it like straight away in your CP journey. Okay, happen down. Oh, I click on a tag instead of clicking on the problem. I see. Yeah, I clicked on the tag and it's opened the tag. Okay. 1552C, interesting. So we have two problems from the same contest, which apparently appears to be Codeforces global, which I missed, unfortunately. However, maybe not so unfortunately, because global rounds are in general div1 plus div2 rounds are a little bit harsher for div1 participants, because it's very easy to lose to some, like, if you are just a master, it's quite easy to lose to some candidate masters, because there are so many of them and not so many of you. Therefore, you can easily lose some rating in case you care a lot about it. Okay, regardless, problem C, maximize the intersections on a circle lies to endpoints with the following property. However, you choose three curves that connect three disjoint pairs of points. No point strictly inside the circle belongs to all three curves. Okay. The points are numbered 1, 2 to n clockwise order. Okay. Initially, k cards connect k pairs of points in such a way that all the k to k endpoints of these cards are distinct. By the way, do I pronounce it right? Okay. Oh, I want here it's. Wait a second. Right. Okay, good. I mean, it makes sense. So initially, k cards connect k pairs of points in such a way that two k endpoints are distinct. You want to draw n minus k additional cards that connect the remaining two n minus k points. In the end, let x be the number of intersections among all n cards. Compute the maximum value that x can attain if you choose n minus k cards optimally. Fascinating. Very, very interesting, actually. That's quite something. Oh no. Okay. I can't say that that's exactly my favorite problem, but number of points, number of cards. Okay. Just does not sound great. I don't know. How even do that like that? It should be greedy, just some greedy. Okay, but what I'm thinking is the following. So imagine that I have a circle. Oh, there was actually a nicer circle here. Okay, we have some cards that are already drawn. Maybe quite strange. And let's say I draw just two simple cards that do not intersect. So that my card, two of my cards do not intersect. I want to say that this is always worse than the same situation where I just changed these two cards so that they now intersect. The way we are going to prove it is like first we add one intersection between red guys. Second, consider any card that intersects both greens. It has to intersect both reds. It just has to. You can see it visually. Now consider any card that intersects exactly one green. It must intersect exactly one red. Because like there is one endpoint out of these four. Right, so we have like 4 endpoints. Purplish guy divides them 2 versus 2. And if like the reds intersect purplish, because the way that they do not intersect, if they do not intersect purplish, then they do not intersect themselves, which does not correspond to the definition of red guys. When we look at the pinky one, it divides endpoints 3 to 1, so obviously at least one card has to intersect it. And if we look at the bluish one, which does not intersect anything, it does not intersect anything, no matter what. So it's always optimal if all of our cards intersect. So no matter how many cards we have to draw, they must all intersect. Whenever you draw something like that, they must all intersect. And because they must all intersect, what follows from this observation is that if you start numbering those guys, so like, well, 1, 2, 3, 4, 5, 6, 7, 8, you will quickly see that, wait a sec, 1 is paired with 5, 2 is paired with 6, 3 is paired to 7, 4 is paired to 8. And therefore, like this construction in which all cards that we draw additionally is uniquely determined. It's uniquely determined, like there is not much to it. The only thing that we have to actually do in this is like, okay, add these guys in, these cards, and compute the number of intersection after we added them. And luckily for us, the number of endpoints is not so great, so we can just we can 100 times 100 squared, yes, like we can just brute force count whether 2 cards intersect or don't. Yeah. Okay, so I want a function that will return whether 2 cards intersect. Oof, that one is a little bit tricky. It's a little bit tricky because, like, the numbers are cyclic in a way. But what I also want is I want like check if what endpoints are still free. So the way we do this is we loop over all taken endpoints and we say like, okay, is free of x is equal to, is free of y is equal to false. Then I can say like, okay, now let me grab a vector free. And what I will do is I will loop over endpoints from 0 to n. And if it's free, then free will get that body in. And then I construct cards. So how do we do it? Let's say that we have that many cards to construct, right? Remaining. So what we do is we'll loop over those guys up to m, and then we say like, okay, e gets in place back of i's free element and then I plus m's free element. And what we want to do is we want to say like, okay, we loop over all pairs of chords, and if they intersect, then we want to say like, okay, we found another intersection. Now the only question that remains is, hello? Yeah, okay, I know that. I could solve this problem, but I will just ignore it. Like you can only do that in C++ 14 or 17, but we do have that, so that's all right. Now, how do we exactly check that two cards intersect? Guess we should just remove some extra cards. It appears to me that one of those guys is okay. I don't actually care for it to be constant. So what I want to do is I don't want to consider too many cases naturally. So what I'm going to do is I'm going to say if first is greater than first second, then I want to swap first and first second. This way I always know that like this vertex is first, this vertex is first second. This vertex will be second first, this vertex will be second once we apply the same operation to seconds. To be honest, this does not have to be in the intersect function. We can instead say like, okay, let's loop over those guys and we say like, okay, if x is greater than y, then we call swap of xy. This way, like first element is in pair is always smaller. And I think that once we have this in place, we can just check that one of two conditions holds. I guess we better break it up in lines like here. So we want to check that first is less than second first and second first. I guess that's a little bit confusing. So how do we do A, B, C, D, right? Also, all right, this now can actually be const. So AB equals AB, CD equals CD. I think that's possible because both CD and AB have the same type, so auto gets inferred. So now what I want to return is like A less than C and C less than B and B less than D, or oh, actually that is also like to not check two cases, we can go even further. I want to ensure that A is always less than C. How do I do it? I sort vector x, y. It will get automatically sorted on the first coordinate. So like I can be sure that once I call this, I have to be careful. I have to call like whoever comes first, I have to call him first in here. So this condition is always satisfied. So I think that I can return just this. That's a little bit like not very safe to be honest, but at the same time, why not? So let's compile that. Nice. Line 34, something went wrong. I guess this is not allowed for some reason. Or maybe I need to add const, or maybe I need to do something else. We'll see. No, that was it. For some reason you can't do what I wanted to do. Okay. Interesting. So something broke. How can something break actually? No, I mean, I think it completely shuts down. Shut down. Oh man, oh, okay. That was a little bit dumb of me. Originally, every endpoint is free and then they become false. If you just 1552, we get 40114 looks legit. I don't really know what to say. That looks legit. So let's try it. Okay, no problems here. Like again, you don't need all of these like tricks on a smarter side. You could just have this function be longer. Sometimes it's better. Like if this takes more time than you loop here, then it may be better. Now that I'm thinking, you can actually like I'm pretty sure that you can group some of those like by I, because I actually determines like the range in which the right endpoint of this smaller guy should be. So we can actually solve the problem in of n log n time per test case. Let's try to do it. So like this condition, CD is xyi. And what we want from it is we want from xyj to have right hand points between those two guys. So how do you count the number of integers in range? Well, first thing that comes to mind is of course indexed set or ordered set, like let's set. Of course, because coordinates are small, you can do all sorts of things, like sure you can do fanfic tree, but this one will be the fastest in terms of how much code we need to add. Somewhere around here. Namespace. Policy-based data structures. Is that it? And that's it. I usually I do that because I sometimes find myself in a situation when I need to change to pair of integers and then back to integers or something like that. So the template using sync is better. However, like the syntax is a bit slightly different. So using order at set equals that. I believe is the syntax. And I'm not sure that we'll be able to check it locally. So it requires GCC, of course. Yeah, but like our idea here is find by order and order of key. Okay. So our idea here is like we don't need to loop over all smaller values of j. So we just instantiate ordered sets that. And here like says cnt plus equals what? Plus equals ordered sets order of key x. We should just do it like that for auto xy and xy. We want to take y minus r or s order of key. Order of key of x and or s insert y, I believe. Let's try it out here. No, that's the wrong problem. Set but not used. Oh, right. That's interesting. Like we actually found how the function intersect should look, and then we can completely disregard it because it gets transformed here. Like the reason how it works is this function actually wants to count how many ABs there are, so that B is between C and D. We can do it by inserting b's as we go into some ordered set and then checking how many values between y and x. Y being D, x being C. So we don't actually need that. And I believe that answers were the same. I deleted a little bit too much. It's a little bit too much. Four, 0, 1, 14 were the correct answers last time we checked. Yeah, it got accepted. I don't know that. You probably can't see the real difference on like n being 100. But overall, this is of n log n, and the previous body was not as good. Not as good. So here I actually recommend this version. Here I think this one is a little bit more involved, but at the same time it's just asymptotically faster. So like could have been like C2, I don't know. I don't really know, that was like nice. Could have been better. Well. Okay, next problem I believe is integers have friends, right? Right, integers have friends. From a recent D1 round, actually, problem B. British mathematician John Litzwood once said about Indian mathematician Srinivasa Ramanujan that every positive integer was one of his personal friends. Turns out that positive integers can also be friends with each other. You are given an array A of distinct positive integers. Define a subarray to be a friend group if and only if there is an integer m with at least 2 such that they are all equal modulo m. Okay. Your friend Gregor wants to know the size of the largest friend group in A. Interesting. Who's Gregor? Does it have any connection with like Litzwood and Ramanujan? Not exactly sure. Note that integers in the input are long, so we need that. They are distinct, interestingly. Okay, so what I'm thinking is that we take a difference array. Oh, nice. I never actually noticed. Oh no, I should really adopt those snippets. Bi gets ai plus 1 minus ai. It fits with a log. Very much though. How are we doing on time? Okay, still got some time. The reason being is like, well, if a group of integers is a friend group, then their differences are all divisible by m, so we like want to find the longest subarray with GCD greater than 1. Naturally, we only care about GCD being a prime number, I believe. Because like if GCD is 6, then we can just say like, okay, that's like, it can't get worse if we take, instead of taking m equal to 6, we take m equal to 2 or m equal to 3. So we care about prime factorization of every number, which we can't find for some reason. It is not great. I believe this is a standard problem, right? It should be. Longest subarray with GCD greater than 1. Yeah, it's classical one. Not subsequence, but subarray. Hopefully, don't just suggest to loop over all subarrays. because that would be unfortunate. No, okay, naive, we don't care about naive. Efficient? Slide and window, yeah, I was thinking about slide and window. Segment tree, why is that, why do we need segment tree? I mean, okay, we can just copy paste that, that works fine with Codeforces rules. Will be extra nice and copy paste that. What do we want? We want to process range queries. That's why we need segment tree. Not exactly sure why we can't do it like in a cheaper way. But this appears to be like very questionable segment tree, if you ask me. Just like it doesn't do much, it just has like range GCD and then what? And then like it has like build function and range GCD, so it should be interchangeable for something nicer, I think. Who writes code like that, honestly? Alright, also, well, we can leave it, that's fine. No, I don't like when the code is like that. It's also, okay, well, let's wrap it into a class, okay? I think that they are logic, like why it should be a segment tree. Was as follows, like when we do something here, oh, we have a sliding window and we need to quickly check whether this is one or not. If it is one, then we have to advance left pointer. If it's not one, then we can keep increasing right pointer. Yeah, so that is like not particularly smart. That is just like not the best memory organization, however. So what we'll do, we will adapt that a bit. Okay, std, I'm not writing std all the time, don't you worry. We'll have public methods and we'll have private fields and I don't know, size is better, right? And vector long integers. I'm not fancy. I don't fancy writing that all the time. We'll just make a template. I always write word type name wrong. Okay, so like tree size. I guess that's all we need. Build. Takes reference to A, does not need to take that because that's just no, I'm used to actual tree vertex, then left and right. Tree. Yeah, that's irrelevant. Just remember, we have vertex in our segment tree, we have left and right. If they are the same, then tree at vertex should get a value array at left. Otherwise, we take middle, we want to call build of left half. So from left, middle. Then 3 vertex is 2 times the vertex. Now I usually have it here and write like that. Now here we want to 3 vertex 2v time plus 1. Here from m plus 1 all the way up to r, and then 3 at vertex gets, yeah, I usually just type 3 vertex all the time so that I know when to use it as an index and when to not. So 3 vertex at TV gets GCD. 3 at 3 vertex gets GCD of 3 at vertex that, and 3 of vertex that. Alright, 3 vertex of course. Yeah, you see, like, do it wrong one time and you will immediately fail. Okay, that needs not be public actually, and I usually don't like it to be public, because what we can have, which is much better, is make a wrapper for it, which will just called build of a, then 1, 0, n minus 1. Want a constructor which will give us a size, and we want to say, like, okay, 3 resize size times 4. That's not ideal. I usually have that at the end, but whatever. What went wrong actually? Oh, I did not close that, and that should be size, of course. It's same as, like, okay, range GCD is actually a good name. Should return t, however, return t. Same way as this actually should take t. Well, segment 3 is implicit, then we have 3 vertex, 3 left, 3 right, and left, right. If left is greater than right, we can return 0 immediately. Yes, but that is better. Otherwise, if left is equal to 3 left and right is equal to 3 right, then we can return 3 at 3 vertex. That's correct. Otherwise, we take 3 middle, and we call GCD of range GCD of 2 times vertex. Otherwise, we call range GCD of 2 times vertex plus 1. Yeah, something like that should work. Now, once again, this is, it's not be public, because it can be better if we provide a convenient wrapper which only takes that and then calls, like, turn range GCD of 1, 0, size minus 1, left and right. That can be const actually, that's a better style. And that can be const as well. Now that part is more or less like clear. So we take, like, segment 3 of size n, and we call, okay, like, we want to actually build. That is incorrect name. The better name is initialize. Hopefully it replaced here as well. We want to initialize it with array b, looks like. here like our maximum length, we say like, okay, take left initialize to 0, right initialize to 0. Oh no, that is actually maybe a little bit easier to understand. So we have like sliding window from left to right. We'll loop while this is at most. If we check if range GCD from L to R is from L left to right is 1, and I hope that I should be fine. We check like we actually should check while if this GC no while I don't understand how the solution passed. So while this body is 1, we increment left. Now at some point it stops being 1. Wait, no, I don't understand. Maybe that's important. So that, come on, really, unbelievable. So that numbers are never always non-negative. Yeah, I will be turning this thing off so that you don't, hopefully don't hear too much noise in the background. Now, normally, I would write it differently, okay? I want to say that I have left that starts here. I want to say that I have right that starts here. I want to say that I loop while right is at most n. I always increment error by 1, and then while segment 3 range GCD from L to R is 1 and both left and right are inclusive. Check if left, while left is less than right, I have to increment left. And now I want to say that, okay, like mx gets maximum of mx and right minus left plus 1. I also print mx plus 1 because remember that I'm in the difference array. That actually makes sense. If it's a template, the only drawback of having a template is that Well, you have to specify the time sometimes, the type. I believe I used vertex here. Nice. Very normal situation with a segment tree, to be honest. It's immediately clear what actually failed. So it couldn't solve even one test case for some reason. And I wonder why. Okay, like if we remove that, right? Okay, so list does not break if you do nothing. It also should not break if you do that. Which is more or less nothing. Right now, obviously, it prints wrong answers. Oh, maybe. Oh, that is just too much, right? It's just a little bit too much. We were out of bounds because we, again, in array B, we only have n-1 elements. So in segment 3, we can only query n-1. Right, so now we get what? 3, 3, 2, 6. Sounds legit. So let's tag that and submit. Runtime error on test 5. Fascinating. I would like to solve the problem by myself, but I also don't want to make the video super long. So maybe check happens. We have like a lot of small tests, right? Does not take much memory, does not take much time, so it's most likely out of bounds. Where is it possible that we get out of bounds? Not very clear. Interesting. So I may want to add this check, which is not meant to fix the runtime error, but it may fix the something else. Wait, how did it end up being this one? Now, what did I submit here? That's more important. No, this one has n-1. When did it revert back? Like this one is supposed to figure out an answer when the numbers are like 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you'll always get L equal to R, so you'll think like, okay, I actually have 1 here, so overall I have 2, but that's incorrect. That one is supposed to fix wrong answer somewhere, but it's not supposed to fix a runtime error. Not exactly sure what is supposed to fix a runtime error though. I'm a little bit worried about how we return 0 from some GCDs. So, oh, okay, I should have just deleted that. I was modifying the wrong file. So what I needed to fix was that actually. If that is not equal to 1, then we can take that maximum. And once again, it's not supposed to fix runtime error. Like 1, 0 should be fine as long as we don't have two zeros. I think that GCD of 0, 0 is undefined behavior, but I don't see how we may be getting two zeros here, if I'm honest with you. It's the same as just 0, right? I don't see what can go wrong. Like, there are so many things that can go wrong, I should say. It's not clear which one is it. Submit once again now because I don't want to waste a lot of your time. Looks like it's again runtime error 5. Interesting. Wait, what? N can be equal to 1? What? If that's a problem, that is also a bit sad, but okay. I'm supposed to output 1 then, right? Very okay. For some reason I was certain it says n is at least 2, but I guess I confused it with another problem that I was solving earlier today. No, it's certainly a runtime error because I'm trying to resize to size 0. That should not work, right? That should fix it, right? Okay. Very interesting. Which number differs? Fourth number? Fourth can 1, 2, 3, 4. So here, for some reason, we output what? What? No, that's not. That can't be. Let me check. One and then these guys. We output 5. I don't know what you're talking about. We output 5. Yeah, obviously. Okay, it got accepted, and I guess I'll have to end the video around here because first of all I already wasted like 1 hour mostly on that problem, and secondly like 3 problems I guess is enough. Like we've seen 3 different ideas. 2 of them were much easier than others. So like here, well, you just have your subset sums. Here, well, you need to do some math with geometry, but overall, like if you use an EU implementation which runs in n squared, then it's fairly easy. And here this same 1800 rated problem in D1, but it's a segment tree. So no, but like okay, this part is standard, I believe, is GCD. So sliding window is again like that is a reasonable solution. I was thinking about something like that, but like I decided to just Google because I was more or less sure that it's a standard problem. So I hope you learned something new today. And with that in mind, I'll see you tomorrow with some a little bit higher rated problems. Let's see what we got in the problem set. We no longer need this, okay. So we solved something like here, yes. Tomorrow I wanted to solve something in 19 to 2000 range. Let's look. Okay, so I guess it will be 2000 then, maybe like this and this. Yes, that's fine. Now both of them are greedy. Oh, I guess that makes sense. This way we'll have like a common theme going through. Okay, so tomorrow I'll see you guys with these 2 problems, and for today that's it. Let me know in the comments if that's okay if I solve the problems like while recording and not in advance, or maybe you find it less informative this way, so then I will try to solve something in advance at least. Well, that's it for me for today. Thanks again for watching. I hope you learned something new, and I'll see you tomorrow with some a little bit harder problems, but not much. Bye bye.